All right, so today we are talking about parallelograms. And of course, the main part of the word parallelogram is the word parallel. So when we have parallelograms, we're going to have some sort of parallel sides. Now, typically, we are going to draw our parallelogram as what I like to think of as a smushed over rectangle to where it would look something like this. Now, we have 5 main properties that we are going to talk about when we talk about parallelograms. Okay, your first thing that I'm going to do is I'm going to go ahead and label our parallelogram as A, B, C, and D. Now, a parallelogram is part of the quadrilateral family because it has 4 sides. So the first property of parallelograms is that both pairs of opposite sides are parallel. Now I'm going to use that OPP to mean opposite so that we can cut down a little bit of writing. Okay, so OPP means opposite. So what are we talking about here when we say opposite sides are parallel? Well, opposite sides have to be across from each other. So one of our opposite sides would be BC is going to be parallel to AD, our other opposite side, at the bottom. Now our other pair of opposite sides is going to be CD and AB. Now remember, we use the arrows to mark that we have parallel sides. Okay, now our second property of parallelograms is that both pairs of opposite sides are congruent. Okay, now also remember that sign, okay, means congruent, which also means equal to us. Okay, and to mark equal sides, remember we use those dash marks. Okay, so our opposite sides are congruent. So here I have the top BC, which would be congruent to AD at the bottom. And then CD would be equal to AB on the opposite side. So both pairs of opposite sides are congruent. Our third characteristic is that opposite angles are congruent. Okay, again, just another thing that we're adding in here are angles abbreviation. Okay, so angles. And opposite angles mean they have to be across from each other. They cannot be formed by the same 2 line segments. So angle A would be congruent to angle C, and we're going to use 1 hoop there. And then angle B is not equal to angle A, so we're going to use 2 hoops, is going to be equal to angle D. So those would be our opposite angles. Our fourth point, our fourth property, is that consecutive angles equal 180. Now when I'm talking about consecutive angles here, we're talking about these angles that are formed, okay, by the same 3 lines. And when we talked about parallel lines and transversals, we called them same side interior angles. Okay, so one pair of our consecutive angles would be angle A and B, so we could say A plus B equals 180. Okay, or you could have B plus C equals 180, and those would be consecutive as well. Our last property deals with our diagonals. Now, remember that our diagonals connect our vertices that are across from each other. So we're going to have from A to C, that's one of our diagonals, and from B to D, that's another one of our diagonals. Okay, now remember when we have bisect, that means we are cutting in half. Okay, so if our diagonals bisect each other, that is going to make this piece, let's call this E, we would have BE equal to DE. And then we would also have AE equal to EC. Okay, so those are our main properties that we're going to use to solve problems. Okay, so getting to our examples, we have quite a few examples here, and I'm going to relate them back to one of our 5 properties. Okay, if we look here and we say find the value of each variable, on number 1 we see 3x is opposite of that box right here. Now we know that that box means 90 degrees, and we know that opposite angles have to equal each other. Okay, so our property that we're using here is that opposite angles are congruent. So to find x, we need to say that 3x equals 90, and we're going to divide by 3, and we get x equal to 30. Now, 4y is not opposite of 90, okay, but it is consecutive to 90. So to find y, we would say consecutive angles equal 180, and we could say that we have 4y plus 90 equals 180. Now, of course, okay, if one of our angles is 90 in this picture, then it would appear that all of our angles equal 90. We get to that 4y equals 90, divide by 4, and we end up with y equals 22.5. Okay? So, moving right along, as we look at number 2, again we say we have this 6x, that is an angle, that is opposite of 90, and we know that opposite angles are congruent. Okay, so opposite angles are congruent. So we can say that 6x equals 90, divide by 6, and we get x equals 15. But with our y, we're not talking about angles at all. On y, we're talking about sides. Okay, now opposite sides are congruent as well. Okay, so opposite sides are congruent, which means we can set 8y equal to 88, divide by 8, and we end up with y equals 11. Okay, so we're using multiple properties to solve our questions. Okay, so as we move along, number 3, we see that we have one dash mark on every single side. If I have one dash mark on every side like I do here, that means that all 4 sides are equal, which means if this is 12, then this is 12, and all of these are 12. Okay, so again, I'm going to use my opposite sides are congruent for both of these problems. So we're going to say 6x equals 12, divide by 6, and we get x equals 2. And we can also use that for y, so we could say 3y equals 12, divide by 3, and y equals 4. Okay? Now, back on number 4, we've got back to angles. Okay, now our angles here, we do have opposite angles. Our opposite angles would be 3y and 12x, but I cannot put x and y in the same problem. Okay, so what we need to look at is how can I solve for x? If I look here at this angle of x and this angle of x, okay, those are consecutive angles. Okay, so we can say that we know that consecutive angles equal 180. Now remember, again, when we're looking at these, this is a parallel line, this is a parallel line, okay, and this is our transversal. Those would be same side interior angles, which means they add up to equal 180. So we're going to say 6x plus 12x equals 180. 6 plus 12 is 18x, still equals 180, and then we can divide by 18 to get x equals 10. Now, we said at the beginning that 3y and 12x are opposite angles, and that opposite angles are equal. So now, okay, we know that opposite of 3y is 12x, and 12 times 10 equals 120. So we could say that 3y equals 120. divide by 3, and we end up with y equals 40. Okay? Hopefully you're kind of seeing how this works and getting the gist of what's happening. Okay, now number 5 we changed just a little bit. We add in this diagonal. Now, back to when we did parallel lines and transversals, if these are my parallel lines and this was my transversal, then this angle and this angle are our alternate interior angles. And we know that alternate interior angles are congruent. So we're still looking at that same idea here with these angles. So if this is 55, then this side would also be 55. Okay, and if the other side is 60, then this side would also be 60. Okay, now, a couple different ways we can do this problem. Okay, and I think one of the best ways to do these problems is to look at our consecutive angles. So with x, our x is right here. Okay, and our 5x would be consecutive, okay, with this whole angle over here. So if we add 60 plus 55, we get that whole angle to be 115. So we're going to say consecutive angles, okay, equal 180. And we could say that 115 plus 5x equals 180. So then we subtract 115, and we know that 5x equals 65. Divide by 5, and x equals 13. Okay. Then we know that 2y and 5x are opposite angles. And we know what x is now, so we could say 5 times 13. Okay, 5 times 13 gives us 65. So we've got opposite angles are congruent. Okay, so we could say that 2y equals 65, divide by 2, and we end up with y equals 32.5, not degrees, just 32.5. Okay? So again, sometimes you have to look and see what's happening before you can just jump right in. Now, number 6, we've got consecutive sides and we've got opposite sides, so we have to figure out what we can find first. Our opposite sides that are congruent are 30x and 150, and then these are congruent at 2y equals 72x, but we cannot put y and x in the same problem. So we need to find x by saying opposite sides are congruent, and we're going to say 30x equals 150. We're going to divide by 30, and we're going to get x equals 25. Okay, then we're going to take that and plug it into x right here and say 72 times 5. Okay, and 72 times 5 is 360. So now we have another opposite sides are congruent. And we can now say that 2y equals 360, divide by 2, and we get y equals 180. Okay, so now we're going to flip to the back, do a couple more examples. Okay, so on the back we get into diagonals. Now remember, our diagonals bisect each other, okay? They bisect each other, okay? And we're going to use some of our knowledge here to figure out how to solve these problems using our triangles. So for all of these exercises, okay, all of these exercises on the back, our diagonals, okay, are bisected. Okay, our diagonals bisect. All right? So if we look at this first one, okay, if our diagonals bisect, that means that this piece and this piece would be equal, and then this piece and this piece would be equal. So we would say 3x equals 12, and then we can just divide by 3 and you get x equals 4. Same thing for y. We've got 4y equals 8. Divide by 4 and we end up with y equals 2. Okay, so that's our most basic problem. Now, you'll notice that on number 2, we have dash marks, which represent that pieces are equal. Okay, if this is 2y, and these have 1 dash mark, that means those pieces are the same. Okay, but when we bisect, that means this piece and this piece are equal. That also means that this piece and this piece are equal, so all 4 of our pieces of our diagonals have 1 dash mark, which means they all equal 28. So to find x, we would say 4x equals 28. Divide by 4, and we would get x equals 7. And then to find y, we have 2y equals 28. Divide by 2. Whoa. Divide by 2, and we get y equals 14. Okay. Now, our third one is a little bit different, and we haven't quite gotten to this part yet. Okay, but we notice that all 4 sides on our third example are congruent. We have a dash mark here, 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 and here, which means these are equal. Now, a little bit later on, when all 4 sides are equal and it's still slanted, we're going to call it a rhombus. And it's going to make our middle angles be perpendicular and be 90 degrees. Okay, so if we look at this triangle, okay, right here, and we know that this is 60, this is 90, then when we have a 60 and a 90, our third angle has to be 30, okay, based off of triangles. Alright, now we also know that this piece and this piece would be equal, which means this angle and this angle are going to be equal. So we need to say that 2x equals 30 because it's a 30, 60, 90 triangle. Divide by 2 and we get x equal to 15. Now, if that angle equals 30, then this angle has to equal 30. So we're going to say 4y equals 30, divide by 4, and we end up with y equals 7.5. Okay, so we're going to have to pull back from our knowledge of triangles to solve some of these problems. Now, on example number 4, this one's where we get a little bit weird. Okay, and we've got to look at our triangles. Now, we know that this piece is 10, which means it bisects this bottom into being equal parts. Okay, so to find x, we're going to say 3x equals 10. We're going to divide by 3, and unfortunately, we do not get pretty numbers. Okay, we get 3.33 repeating on this problem. Okay, now we have to look at y, and to look at y, we're going to have to look at our triangle that we have here. Just like we just talked about, okay, when we pull out this triangle, we have a 30-degree angle here. We have a 90 here, which means this has to be 60 degrees. Okay, and this side is 10. Now, this should look familiar. We haven't gone too long without talking about this. We have a 30, 60, 90 triangle. Now, remember, when we have a 30, 60, 90 triangle, okay, we have Mama Bear, Papa Bear, and Baby Bear. We have m, 2m, and m square roots of 3. Okay, now we are looking for the part that is across from our 60-degree angle, which is going to be our mama. This is across from 60, this is across from 30, and this is across from 90. And they give us the part that's across from 30, which means they give us Baby Bear. Now, when we have the baby and we want to go to mama, we are getting bigger. So we want to multiply times the square root of 3, and we're going to end up with y equals 10 square roots of 3. Okay, I told you that triangle stuff wasn't going away, and it's not. All right, so next one, we still are going to have some triangles involved here. Okay, if we look here, we've got a right triangle right here because of this 90, which also means that this angle is going to have to be 90 down here. Now we know that this piece right here is 12, which means this diagonal is 12. Okay, and then on the other end of this, we know if this is 2y, then this would also be 2y. Now, to find x, we see that we have the same number of hoops, and if it's a right triangle and those angles are equal here, okay, our only right triangle, we say 180 minus 90 is 90, divided by 2 is 45. Okay, so 3x equals 45, divide by 3, and we get x equals 15. Now for y, if those two are equal, then we know that these two are equal, okay, which means this is 12 and this is 12. And again, we have to pull back in our 45, 45, 90 triangles here. Okay, so if I have a 45, 45, 90 triangle, okay, and this is 90, and this is 45, and this is 45. This is when we had the twins, right? This was m, and m square roots of 2. Okay, we know m is 12. So m square roots of 2 is 12 square roots of 2. So we can say that 2y equals 12 square roots of 2, divide by 2, and y is going to equal 6 square roots of 2. Okay. Now this last one gets a little tricky. Okay, and for right now, I think... Okay, so we are going to keep going here. So what we have to look at here is a little bit different. If this is 4, then this is 4. Okay, now when we have a right triangle in this case, if this is 17, we know that the top is also 17. Okay, and we have this as our right triangle. Okay, and we can now find x based off of our right triangle. Okay, we have 4 plus 4, which is going to be 8. Okay, and then we've got our hypotenuse across from 90 is 17. And this is x, which is what we're trying to find. Okay, so we're going to say 17 squared minus 8 squared equals x squared. Okay, now when we're using Pythagorean theorem right here, right, 17 squared is 289 minus 64 equals x squared. You subtract, you get 225 equals x squared, and the square root of 225 is 15. Okay, so x equals 15. Now, to find y, that's a little bit different, because if this is 15, then you know that this is 15. Okay, and if that is 90, then you know that this angle is 90. So here in this triangle, what we have is we have 90, 4 on the bottom, 15 on the vertical leg, and y on our hypotenuse. So we're going to do Pythagorean theorem one more time. Okay, we get 4 squared plus 15 squared equals y squared. You get 16 plus 225 equals y squared. And when you add 16 plus 225, you get 241 equals y squared. And then you square root. Now, in this case, we would normally try and simplify. Okay, but for today, we are just going to leave it as square root of 241. Now, the last thing that I need to talk to you about with parallelograms is on a coordinate grid. Okay, if we want to find the coordinates of the intersection of the diagonals with the given vertices, we know that our diagonals, okay, based off of our picture here, okay, I've already graphed the points, but you'll want to graph the points. Okay, this is A, this is B, this is C, and this is D. So our diagonals would be from A to C, okay, and from B to D. Now we know that our diagonals bisect each other. Now if they bisect each other, that means that they cut each other in half, or 2 equal parts. Now we want to know where they intersect. Okay, and if they intersect each other halfway, that means that we are looking for the midpoint. Okay, now we haven't talked about midpoint in a long time, since the beginning of the year, but our midpoint formula is x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So you really only need to pick one of your diagonals. Okay, for our case, I'm going to use AC, so I'm going to use point A and point C. So we have x1, y1, and we have x2, y2, and we're going to say that we have 3 plus 3 divided by 2, comma, then for our y's we've got 6 plus negative 2 divided by 2, and we get 3 plus 3 is 6, divided by 2 is 3, and 6 plus a negative 2 is a positive 4, and positive 4 divided by 2 is 2. So your midpoint would be 3, 2. Now, you could check that out with your other ones, right? And you could say, okay, I have 5 plus 1 divided by 2, and I have 8 plus negative 4 divided by 2, 5 plus 1 is 6 divided by 2 is 3, 8 plus negative 4 is 4 divided by 2 is 2, and they check out. Okay, you should get the answer either way you go. Okay, so your midpoint is over 3 and up 2. And that's where your intersection of your diagonals would be. I hope this helps you out with parallelograms. Sorry it's so long. Good luck.